Okay, this is homework number 5, and these problems really are not going to vary too much from the notes. So if you watch the notes, you're seeing the same exact problems here. Um, okay, so I have 7x plus 6y equals 4 and 9x plus 6y equals 12. So you always want to make sure that everything's lined up. And they are, okay? So everything's lined up. The next thing you want to look at is see which variable you're going to be eliminating. While the x's have a 7 and a 9, those are nowhere near the same. But the y's do have the same, 6y and 6y. So the question is, do I add these two equations together or subtract them? Well, the idea is that you need those y's to go away. So if you added those two equations together, 6 plus 6 equals 12. Those y's aren't going away. But if you subtract, okay, 6y minus 6y, they go away. So if you like to distribute that subtraction sign and then add them together, that's fine. Or you can just subtract as you go along. So I have 7x minus 9x equals negative 2x. 6y minus 6y go away equals 4 minus 12 equals a negative 8. So what you did when you subtracted those equations from each other, you created one equation with one variable. And since you've got that, you're going to be able to solve for x. So I'm going to divide by that negative 2. Negative 2 divided by negative 2 is 1. 1 times x is still just x, so those go away. And you're left with a positive 4. Great. So we found one part of our answer. How do you find the other part? All you have to do is plug it back in to either one of those equations up top. And it doesn't matter which one. I'll pick the top one. You pick the bottom one, that's fine too. All right, I'm going to erase that. And I'm going to have 7 times 4. So that's 28 plus 6y equals 4. I'll subtract 28 from both sides. Oops. And I'll have 6y equals negative 24. I'll divide by 6. And I'll have y equals negative 4. So that's your solution, meaning if you plugged in 4, negative 4, those equations would be true. If you graph those two equations, that's the point at which they would cross 4, negative 4. Okay, let's look at the next one. I won't do very many because they're all very similar. Here with this one, everything's lined up perfect. The x's do not have common coefficients, but those y's do. Now, I know they're not exactly the same. You have a positive 3y and a negative 3y, but honestly, that almost makes it a little bit easier because now we can add our equations. So, negative 8x plus 13x leaves you 5x. Positive 3y plus negative 3y go away. And 3 plus negative 18 is negative 15. So when you add those equations together, you're left with one equation with one variable. So now you can solve. And I'm going to divide. So I get x equals negative 3. Okay. So what do we do with that? Now it's time to take this and plug it back into any of those equations over there. So I have negative 8x plus 3y equals 3. I'm going to plug x in, negative 3 in for x. Negative 8 times negative 3 is a positive 24, plus 3y equals 3. I'm going to subtract 24 from both sides. Okay, and I have 3y is equal to negative 21. Finally, I'll divide by 3, and I'm left with y equals negative 7. So my solution is x equals negative 3 and y equals negative 7. Okay, I'll work out one more, just in case we're having a little trouble with this. But as we're working through these, think about all the methods we've used. We've used graphing, we've used substitution, we've used elimination. Um, which ones have you liked more? Which ones did you not like? Is there any ones that you don't understand that we need to go over again? Okay, so all of my variables are lined up. I think Alex makes these solving systems pretty nice, okay, and does a lot of the prep work for you. Now, my x's are opposites of each other, 3 and -3. So that's going to be nice. I could just add those two together and they'll automatically go away. So then I have -y plus a positive 13y, leaves me 5y equals a 7 plus -17 equals a -10. So we're left with one equation with only one variable. So I can solve for that y. And I get y equals -2. Now from there, all you need to do is plug it back into either one of those equations. You could do the top one, you could do the bottom one. Usually look at it and see if there's one that's easier, but they're kind of looking the same. So instead of y, I'm going to plug in -2, right? Because y equals -2. 3x, -8 times -2 is a positive 16 equals 7. I'll go ahead and subtract 16 from both sides. So I get 3x equals -9. Divide by 3, and I got x equals -3. So my solutions, okay. I won't work out the rest because like I said, they're all the same. I didn't do any variation in these. Tomorrow we'll continue elimination, but we might have an extra prep work step that we got to do. So if you have any questions, let me know.